Very simple to write some equations in covariant form. Since I wrote Maxwell's equations, let me also write what is called Klein-Gordon equation. This is the equation that was written for the quantum mechanics of relativistic particles, but it turned out that it was not the correct equation because it gives rise to probability densities that are non-positive, that means even can become negative. So the equation is something like this. You have del square minus 1 by c square into dou square by dou t square into plus perhaps I have some quantity I can see by h cross. Okay, the form of it is very easy to understand. You know, in energy momentum relation is E square is equal to P square C square plus M square C to the power 4. This is the energy momentum relation. And in quantum mechanics, you have a correspondence. Wherever E is there, you write minus dou by dou t, IH cross dou by dou t, and where P is there, the momentum is there, you write minus IH cross del. And if you write this, you will have minus h bar square dou square by dou t square plus this is equal to this into some psi. Psi is the wave function corresponding to relativistic particles state, and this will be minus h bar square del square h bar square c square del square plus m square c to the power 4, this whole thing into psi. This is called Klein-Gordon equation. So I can write it, pull out c square and cancel with this. So I can write this as del square minus 1 by c square into dou square by dou t square, del square psi minus this is psi. And so what will you get? I have to take this side, so that means it is minus m square c square by h bar square. M square c square by h bar square into psi is equal to 0. Now you can see that this can be written in the following fashion. You know that del mu is 1 over c times dou by dou t into del. The space components are this. And dou mu is minus 1 over c dou by dou t del. So what will you get if I write del mu is del square minus 1 by c square dou square by dou t square. Correct? So you can write this equation as dou mu minus m square c square by h bar square into psi is equal to 0. So this is called the covariant form of Klein-Gordon equation. So I am writing dou mu, and this is anyway scalar. So this is the covariant form of just like continuity equation. This is also very simple to write in the covariant form. So it is invariant under Lorentz transformation, so it's a correct relativistic equation, but only thing is the interpretations of probability density in terms of psi is not correct, because there is a second derivative with respect to time, you will have a probability density which can become negative. An expression, if you write in Schrodinger equation, you might have written, you write Schrodinger equation for psi and psi star and then subtract one from the other, you get probability continuity equation. You have a charge density, current density and probability density. If you write such equation, you get a probability density which can become negative. So that was the problem, and hence this was abandoned as a candidate for relativistic equation for relativistic particles, which later entered into theory as a correct equation for quantum mechanics of field of spin zero particles. Okay. Now let me